Okay, so we do need to make sure we understand function notation and transformation. So we're starting with original function square root x. And then we have the inside and outside transformations. I'm just going to start with the outside because the outside is nice and easy, right? So my change in y is going to be, I'm going to times my original square root function by -2. So I end up with 0, -2, -4, -6. So I transfer my x's and my y's separately. My x's are the inside part. There's lots of different ways to do it. I can undo all this algebra. The notation is exactly opposite of what I'm actually going to do. Okay, I could put this into factored form and just do it always as shift first, and then, expand, compress first, shift last. So I think I'm going to do that for this one here. So I'm going to change my notation here. Okay, so I'm just going to not undo anything. I'm just going to change the notation. Okay, so it becomes 3x minus 6 over 2 plus, and I'm going to write that 1 as 2 over 2, and then I can just put that all together. So I get 3x minus 4, okay, all over 2. And then in factored form, the 2 is already factored. If I just factor out the 3, I get 3 over 2 x minus 4/3. And now these two expressions, in fact, this expression and this expression are exactly the same, but one is in the factored form. So I can just do this as compress by 2/3, shift to the right 4/3. So this is one way to do it. The other way is I can undo all this notation and do everything backwards. That would be the other option. So there's a few options here. So I'm going to rewrite this equation. I'm going to write this as y equals, okay, the -2 is on the outside. I've already dealt with that. Okay, square root. Okay, so instead of writing this part here, all this is going to be converted into 3 over 2 x minus 4 over 3 factored form. So I know the process of this is going to be, the first step is change in x is going to be, it's a horizontal compression by 2/3, and then shift last, horizontal shift plus 4/3. Okay, so I'm just going to apply that. So it's going to times it by 2/3 and add 4/3. So 0 times 2/3 plus 4/3 is 4/3. 1 times 2/3 plus 4/3 is 6/3, or 2. I get 4 times that is 8/3 plus 4/3 is going to be 12/3, or 4. That's going to be 18 plus 4 is 22/3. Okay, so this is very useful to do factored form. When you actually undo the algebra here, you actually get the calculation to actually do the transformation. So if I were to actually do the change, it would look like this. So this looks like this. So 3x, this is actually my new x, and this notation actually gets me back to my old x. Okay, this is the way that the order in which this happens through the function flowchart. It's actually going backwards through the function flowchart, so I actually need to solve for the other x. So I'm going to do this in steps. So I'm going to end up with -1 times 2 so that's going to be plus 6, and then it's going to divide everything by 3. Okay, and this calculation will give me the exact same transformation as I got here. So I take all these numbers, put them through here, and I'm going to get those exact same numbers here. Okay, so any way you do it is perfectly fine. Just make sure you understand the idea of transformation. Good to know the factored form. And once I've done this transformation, I'll just these points, it's going to be 4/3, 0. Okay, 2 over, 2 down. 4 over, 4 down. That's going to be 7 1/3. So 7 1/3 is going to be 4, 5, 6, 7 1/3. -6, right about there. It's going to be, this graph is going to look like that. Okay, so there it is. There's my transformed graph. Okay, so the last part here is we want to be able to deal with functions in tables. Okay, so we dealt with function equations, functions with graphs, now functions with tables. Okay, so if I want to find out f of 0 plus g of 0, I just go straight to my table, f of 0. Okay, so I'm going to just highlight this in red. F of 0 is 0. Okay, g of 0 is 1. So I'm going to end up with 0 plus 1, that equals 1. F of g of 8, that means the inside is g, so I got to start with my inside. G of 8 is 7, and then I got to use this 7 as the input for my outside function f, so I end up with f of g of 8 equals 5. Okay, so again, make sure you understand how this flows through there. So this one here is now the inverse. So I have to inverse of g of 2. What does that really mean? That means the g of x equals 2. So that means my output is 2, and I'm doing an inverse. So I'm going from the output to the input. That's really 1. So I'm just better write this down. This is going to be f. This becomes f of 1. Okay, maybe I'll do that in green because it's coming from the green table, but that is equal to 1. And f of 1, if I look at my red table, f of 1 equals 1. How did I get that 1? Well, I interpreted this inverse. This g of inverse of 2 means that my output was 2, and my output was my old input, which was 1. Okay, so that's how inverse works. How about this one here? I take the inverse of f 15. That means that my output was 15 and my input is what I'm looking for, and I'm going to put the input into my f, and I want to know what the output is. Well, there is no 15 as my output here, so this almost seems impossible, except if you understand that the inverse of an inverse is back to where we started, this really just ends up being equal to 15. The inverse of the inverse just undoes it. Okay, it's like times 2 divide 2, right? So if f is times 2, inverse of f is divide 2. So if I divide 2, then times 2, I undo them, end up back with what I started. So I'm going to put a star next to this one because this is important to know, because that's always a good way to, it's a simple solution because one undoes the other. There is a link for that as well, so you can see it geometrically as well on a graph if you want to see the inverse of an inverse. Okay, so this link actually refers to this problem. And the last one here, if I inverse 1, means the output is 1. I want to know the original input. Okay, well there's my output of 1. My original input then is 1. Okay, so then I'm just going to do this in steps. This becomes the inverse of g the inverse of 1. Okay, so what does this inverse notation mean? This means that this is the output, and I want to know the original input. Okay, if my output is 1, my original input must be 0. So then this must be equal to 0. Okay, so if I map it through, the inverse of f of 1, okay, that means that my output was 1, my input was 1, so then I go to the 1 here. The inverse of 1 means the output was 1, and I need to get back to the input, which was 0. Okay, so if we can understand how to map this on a table, this is something that we want to make sure we understand how to do as well.